All right, welcome to lesson 1.3. The title of this lesson is A First Look at Limits. The objectives are listed below. Exploring long-run values, we want to begin to understand the concept of limits, and we want to talk about the shifted geometric sequences, and we're going to use algebra to find the long-run value. Now, you've done the Skittles investigation, and you notice that in particular, part 1 and 2 has the same long-run value. So no matter what you do to it, it stops at a certain point. Part 3 and 4, same thing, and part 5 and 6 are the same thing. So at some point in this lesson, we are going to use algebra to find that long-run value so that you're not constantly moving the Skittles around and that you're not always having to rely on the sequence mode on your calculator. So let me give you the definition. Geometric sequence is when you multiply by a common ratio. So again, the recursive rule is that u sub 1 or u sub 0 is equal to something. Un is going to equal to the common ratio times un minus 1. N has to be greater than a certain number. Usually we say 2. A shifted geometric sequence is the one that we explored yesterday, and that is, or during the Skittles investigation. So again, it still start out to be the same. You still have to have a u sub 1 or u sub 0. You always need that starting value. And then you have the un is equal to some type of constant common ratio times un minus 1, but you're also now adding a constant. Okay, so let's add that also to your list of vocabularies. And again, that is shifted geometric sequence. All right. As I mentioned during the first slide, that you'll notice that each part of the investigation approaches a long-run value. What that means is it levels out no matter what you do to it, whether you're taking away something, the number of Skittles, or you're adding a number of Skittles. I am actually going to refer to part 5 and 6 of the Skittle investigation. All right, so here's a quick recap. Part 5 says that the keeper begins with 50 Skittles. So I'm going to start my u sub 0 with 50. And then the taker takes 25% of the Skittles. So my un is going to equal to un minus 1 times 1 minus 0.25. Because the taker is taking away 25%. But the giver will also give 15%, or 15 Skittles, 15 more Skittles. This is the recursive routine for part 5. All right? Now, for part 6 start out with the keeper begins with 30 Skittles. The taker takes away 25% and the giver gives 15%. So the recursive routine essentially is the same. 1 minus 0.25%. I'm missing a minus there. And the giver gives 15. Now, if you did the investigation yesterday, you'll notice that the long run value for both of these parts, or these two parts, stops at 60. So what we want to know is, how do we get to 60 without actually having to put the entire thing into your calculator and press enter 100 times? So we're going to use algebra to find the long run value. Now, both of these starts with 60, or ends with 60, but they start at a different number. So here's what I can do. I can ignore what the starting value is, because it really doesn't matter what the starting value is. It will still end at 60. All right? So let me take an example here. Suppose I'm looking for the 1,000 term. I don't know what that number is. Let's call it W. All right? If I want to know what the 1,000 term is, I need to know I need to take the one before that, and the one before that is 999. And I'm going to multiply it by 0.75. And I'm going to add 15. The 0.75 right here came from the 1 minus 0.25, and the plus 15 is just what the giver gives. If it stops at W, then the term before that would also be W. Meaning that it levels out already. It doesn't change anything anymore. All right? So let me replace a couple of things. Well, U sub 1000 right there is equal to W. So I'm just going to replace that with W. And that will equal to W. Because it levels out, so the terms before that has to be the same. I'm going to multiply it by 0.75. And I'm going to add 15. Now this is just an algebra problem. Let me rewrite this. W really means 1W. W times 0.75 means 0.75W. And I'm going to plus 15. I'm just simplifying some of these multiplication. And I notice that both on the left-hand side and the right-hand side has a common unknown value of W. So what I'm going to do is I'm going to bring them together. So what I'm going to do next is I'm going to subtract 0.75W from both sides. Get some spacing in here. All right. Now, here's what I have. 1W minus 0.75W becomes 0.25W. That will equal to, well, 0.75W minus 0.75W will be 0. So then I have 15. To undo that 0.25 times W, I'm going to divide it by 0.25 on both sides. So now 0.25 divided by 0.25, well, that gets me just W by itself. And if you take 15 divided by 0.25, you get 60. So the long run value is 60. Okay? I'm using the letter W, but you can use essentially any letter, and it will still get you the same number. Okay? I'm letting W be my long run value. That's the value that it won't stop anymore. And if you did the investigation yesterday, you notice that it stops changing after about 50 turns. So by the time that I'm looking for 1000th term, it's done. The value stops changing, and that is my long run value. All right? And that's also known as the limit. When you get to calculus, they're not called the long run value anymore. They're called the limits as the function increases. So again, that's using algebra to find the long run value. Okay? Let's get one more example in. Now I'm looking at part 3 of the Skittle investigation. I notice in part 3 it says the keeper begins with 10 Skittles. So U sub 0 is 10. UN is equal to UN minus 1 times 1 minus 0.40 plus 5. Okay. 1 minus 0.4 is because the taker was taking 40% away. The plus 5 is when the giver gives 5 more candy. Okay. So again, we're looking for the long run value. We're looking for the value in which it stops changing. So what I'm going to do is I'm going to let W be that number, okay? That long run number. I don't know what it is, okay? But here's what I'm assuming. We're so far out in the sequence that the number before that UN is not going to change anymore either. So it's going to be W as well. Okay? And we're going to multiply it by 0.6. I'm simplifying. I'm simplifying the 1 minus 0.4, and I'm going to add 5. All right, let me rewrite this so it's a little bit clearer. W, again, means 1 W. That will equal to 0.6 W plus 5. Let me combine like terms. I'm going to subtract 0.6 W from both sides. So I'm going to get 0.4 W. It's going to equal to 0 plus 5. Well, that's just 5. And then to get W by itself, to undo that multiplication, I'm going to divide by 0.4. So then that long run number, that limit, that long-term value, that long run value that I'm looking for is 5 divided by 0.4, which is 12.5. So if you did the investigation, you're going to notice that it will equals to 12.5 for part 3 and part 4. Again, what determines that long run value is the recursive routine, not the starting value. The starting value has little to no effect at this point. Okay? Let me make this a little bit bigger so that you can see it. Again, the long run value is 12.5. The limit is 12.5. Okay? That's using algebra to find the long run value. So let me summarize the lesson. You have arithmetic sequence, and that's linear. It is either decreasing or increasing. It is decreasing by the same amount or increasing by the same amount. Geometric, it's curved. It's usually decreasing. If it's decreasing, it will level out at 0. Okay. Shifted geometric, it's also curved. If it's decreasing, it levels out at a value that is non-zero. So any other value at non-zero. If it's increasing, it will also level off. So that's how you can tell the difference between arithmetic, geometric, and shifted geometric. Let me make a graph of that. This is arithmetic. Same amount, same value, common difference. Geometric, if it's decreasing, it usually looks like this because it will level out at 0. If it's increasing, it looks like this. Shifted geometric, if it levels out, it will level out at non-zero. If it's increasing, it will also level out. We're going to explore more graphing of our sequences in lesson 1.4.